Hello class, we are still on an extension program powered by exponential computers, referred by Aliulal Physics Lesson 9. So if you could remember class, our last class previous we talked on simple harmonic motion. So we are still on simple harmonic motion. So if you could remember class, you can remember the definition of simple harmonic motion, and we give types of simple harmonic motion, and we give some examples of simple harmonic motions. So we are still continue from where we stop. We're still focusing on simple harmonic motion class, because the topic is deep. The outline. This is our today's outline. This is what we are focusing on today. Definition of period, frequency, amplitude of simple harmonic motion. All these things are under simple harmonic motion: period, frequency, and amplitude. So let us see how the relationship of period, frequency, and amplitude of simple harmonic motion, how their relationship are, how they are. Period class. When we say period or time period, it's a time taken by a body to complete one oscillation. It's known as period. So when we say period class, it's a time taken, the total time that cover to complete one oscillation. When we say one oscillation class, let us take a cycle. When we have a cycle, let us say we are going to round the cycle. So as we are moving, the time taken that our watch is moving is what we call period. We want to know how many times are you taking to reach the place or to complete the oscillation of an object or a body. It's donated by T. This is what is donated by. When you see T is time period, T is equals to 2 pi all over omega. This is what we call time period in simple harmonic motion, and it has SI unit. So the SI unit of time is second class, right? This is the SI unit, so the SI unit of time is second. So it measures by second, is donated by T. Frequency. When we say frequency, it's a number of oscillation. If you could remember last one, we say last in period, we say is a number of a body, and the amount of time used to cover a oscillation. But a frequency is a number of oscillation. How many oscillations are we taking to complete by a body in 1 second is called frequency. So the amount of oscillation that we take or that we have to complete it by a 1 second is what we call frequency. So let's say we are having a pendulum. A pendulum bulb is moving to and fro within a second. Let's say it's move 1 2 1 2 in each second. So the amount of oscillation that go to and fro that the object move is what we call frequency. The frequency is a number of oscillation to complete by the body in 1 second. It's called frequency. So we donated frequency as V class. V. You see the SI unit, and it has SI unit. The SI unit is has. Anywhere you see has, we are referring to frequency class, and it's measured by seconds. Then amplitude. When we say amplitude class, it's a maximum displacement in any direction from a mean position is called amplitude. It's a maximum displacement. Any displacement in any direction, it means position. So amplitude is a maximum displacement in any direction from a mean position. When we say from a mean position, from initial position, this is what we call amplitude. And it's denoted by A, small letter A. Now you guys are smart, so when we went to university, you understand all these things. This is small a. So examples. This is the example. A simple calculation gathered the period, frequency, and amplitude. We say a body of a mass. A body has a mass, a weight. I know you understand that class. Why? Because you are smart. Is suspended from the end of spring hose. Force constant is near 0.4 Newton per meter. The body is set into a simple harmonic motion with amplitude 0.2. So class, we say a body of mass of 20 grams is suspended from the end of a spring whose force, the amount of force that used is 0.4 Newton per meter. So the body is set into simple harmonic motion with amplitude 0.2 meter. So we are asked to calculate period, the period of a motion, the frequency of a motion, then the angular speed and total energy. So let us see class. This is a period. If you could remember, I have gave you the formula that used to calculate period. So this is a period. Already our values is given. So T is equals to 2 pi root of M all over K. So this M is representing as mass. As you can see, this is our mass. So this is the M. But you see, the M here is 20 grams. So we have to convert it into kilogram. So when we are to convert it into kilogram, we have to divide it by 1000. When we divide the object by 1000, it will give us the exact value. So when we divide it by 1000, it will give us 0.02. And the K is a force. This force, the constant force, is our K class. So we are to add them and calculate. To calculate period, the time taken. So T is equals to 2 pi into root of M all over K. This is the formula for period. And this is equals to 2 pi into root of, we insert our values. This is our m, and this is our force, constant force. We insert it here. 3 times this phi. You all know that phi is represented as 22 all over 7. When we divide 22 over 7, it will give you 3.142. You guys should press your calculators and see. And 0.2236, when we divide this of mass by the constant force, it will give us 0.2236, you guys. So when we times 2 times 3.142, it will give us 6.284. You guys should use your calculators. Times root of our mass and constant force. This is our normal values, times, when we root these numbers, it will give us 0.4729. You should take your calculators. First of all, press root. Anywhere you see root, press it, then insert your values and press equal sign. It will give you this. So you can just times 6.284 times 0.4729. So this is our second. This is our t, time or period that the object is take to complete the oscillation. This is it, class. Then frequency. So if you remember, we say frequency is a total oscillation of a body covered by a 1 second. So this is a seconds, class. This is 1. Anywhere you see 1 over t, f is equals to 1 over t, we means period. Anywhere in physics you see it, it means period. So this is 1 second. So from the meaning, we said it's a total oscillation covered by 1 second. So this is the time taken. This is our equal sign. This is 1 all over. This 2.9719 is our value that we calculate here. You see, our t. So we have to just insert it here. Why? Because our formula is say 1 all over t. So you have to just insert it. You see. So when we divide 1 all over 2.9717, it will give us 0.3365 hertz. I have told you earlier that our SI unit of frequency is hertz. So this is the total oscillation covered by 1 second. Have you understand it, class? So the angular speed. When we say angular speed, as we have told you earlier, this is our angular speed, the angles of an object. So our formula to calculate angular speed is omega is equals to 2 phi f. This f is represent our frequency. This frequency that we calculate. You guys are smart. You understand that. So we have omega is equals to 2 phi f. It is our angular speed, the speed of an angle used to oscillate the object. Then we said 2 phi. So if you could remember, class, we have already calculated our frequency. This is our frequency, class. This is it. So we just take our values to insert it here. Why? Because we have frequency and we are looking for angular speed. Then we can just insert our values. This F frequency is represent the value that we calculated for. Then 2 pi times the value of frequency. So this is what we give us. 2 times 5 is the same thing as 3.142. As I have told you earlier, if you divide 2012 over 7, it will give you this. And then our frequency, this is our frequency. So if we times all these values, it will give us 2.1146 rad per second. So this is how to calculate our angular speed. So thank you, class. Thank you for listening. You can subscribe to our YouTube channel as Exponential Computers for more recordings. I know you enjoy our lessons. You guys are smart. Thank you. See you next time.